So now the third problem of the Kotlin Heroes episode 7 is C, that is sweets. Okay, so I will quickly go through the problem statement and I'll try to explain it through an example so the problem becomes more clear. Okay, so basically what we have given that there are n delicious sweets on a circular table. Okay, and for convenience it is arranged in a clockwise direction from 1 to n. Okay, and for each of the sweets it is known whether Anya likes it or not. So it will be given which are the sweets that Anya likes and which are the sweet basically which Anya likes. So it will be given as it says that it is known. Okay, now Anya decides that she should eat all the sweets that are on the table and she likes them. Okay, now eating the sweets in random order becomes too boring according to the Codeforces, so they have made a game. So basically there are 3 conditions in the game. Okay, so if there are no sweets that Anya likes left on the table, then the game ends. So it is like previously it is stated that there are certain sweets that is known, that Anya likes. Okay, and at the very beginning of the game, so in the starting of the game, if there is at least one sweet on the table that Anya wants to eat, she eats the sweet number 1. So like in the starting of the game we know that we have at least one, okay, sweet that which Anya likes. Okay, so we won't eat any of the sweet but the sweet number 1. Okay, now after Anya has eaten some sweet, she count k sweets clockwise. Okay, so after she has eaten one sweet, basically the first one. Okay, what's because in the starting what she does, she doesn't eat anything but the first sweet if there is at least one sweet on the table which she likes. Okay, so she counts k sweets clockwise. So basically k would be given, so k sweets clockwise starting from the next sweet in the circle. Okay, so next sweet basically because the previous one was eaten, so from the next sweet she counts k. Okay, including that sweet also. So she counts k and eats the kth sweet in the count. Okay, and in the bracket it is said that if there are less than k sweets in the circle, some sweets can participate in the count more than once. So basically it's nothing but as it is said that we have arranged it in a circular table, so like it never ends. We can, where we have started, we can like again come to that point also, then we can again start. So that's what kind of thing it has said. Okay, and one more thing, the sweets that have already been eaten do not participate in the counting. Now there is an example which is given, like this 6 sweets be arranged in a circle. So basically 1 to n sweets are arranged in a circle, and Anya likes the sweet number 4, 5 and 6. So 3 sweets that she likes. Okay, and k equals to 4. Okay, so k equals to 4. Now the game as follows, it is given the example. Okay, and at the end we have to say number of sweets that Anya will eat. Now I have taken this same example and try to represent it more graphically in here. Okay, so I have sweets from 1 to 6 which are arranged in a circular table. Okay, in a clockwise direction, and there are 3 sweets that Anya likes which are 4, 5 and 6, and the k equals to 4. So k is basically the count that she will count and eat the kth sweet after the first one. Okay, so now we have in the starting we have 3 sweets, 4, 5 and 6 in the table that Anya likes. So we have like more than one. Okay, less more than or equals to 1. Okay, so if it is the condition, she won't do anything, but she will eat the first sweet. Okay, so she will eat the first sweet, and I'll mark the sweets which have been eaten as this arrow. So one has been eaten. Now what the problem statement was, that after she has eaten some sweet, she counts k sweets clockwise. Okay, so now she will count k. So k is 4, so 1 2 3, sorry, 3 and 4. So this is the fourth. So now she will eat this fourth sweet, and the procedure will repeat until and unless we are done with all the, we have eaten, or she has eaten all the sweets that she likes. So the next sweet she eats is 5, and 5 is, I'll show you, it is one of the liked sweets. So 5 have been eaten, so I will mark 5 as eaten. So how to mark it? Okay, so I will say just it has been eaten. Okay, so 5 has been removed from the liked list. Okay, now we are left with only 2. Okay, so now 5 has been eaten. Now from the next suit we will again count k. So from 6, 1 is eaten, so we won't count this. So 6, from 6, 1 2 3 and 4, this is the fourth one. So now next she will eat this fourth sweet. So now again this 4 has been eaten. Okay, so I will mark this 4 as eaten as well. So now this 4 has been eaten. Okay, now still we are left with one lacked sweets. So now after 4 has been eaten, so it will start counting from the next sweet that is present in the table. So it is not 5 because 5 has been already eaten, so it is 6. So from 6 we will again count k. So k is basically 4. Okay, so like it will go like 1 2 3. 1 minute, I'm thinking is something wrong in here. Okay, so basically the first time she eats the first sweet. Okay, and after that she counts k equals to 4 from 2. So 2 1 2 3 4. So after that she eats the fifth one. Okay, so as it has shown in here, and after that she counts from the sixth. Okay, sixth. So yeah, after that she counts from the 6. So she eats like 1 2 3 4. So now next she eats the fourth one. Okay, great. Okay, now still we are left with the sixth suit that is in the liked list. Okay, so now she again will count from the sixth one because 5 has already been eaten and 6 is left on the table in the direction. Okay, so she will count from the sixth one. So 6 1 2 3 and 4. So it will again come back to 6. So now 6 has also been eaten. So we are left with all the suits. So we are done with all the lacked suits. So all the lacked suits in the table has been eaten, and we have to just do the operation until unless we are not done with the lacked suits. So now at this point of time we are done with the lacked suit. So how many suits we have eaten so far? 1 4 5 6. So 4 suits. So the answer would be 4. Okay, so that answer we had to find out. So this was the sort of answer. Okay, and it's just only that we have to do in here. Okay, now the question arises that how to do this in code. Okay, because it's graphically we have represented it, but how to basically do it in if we want really to code it. Okay, so the first thing that came in my mind like the very quickly was to use a queue. Okay, because why queue? Because we are counting k. Okay, we are basically counting k, so we are not removing those like k minus 1 elements. Okay, but we are, those elements are still there, but we are moving k times, and the kth suit we are removing, okay, from the table. So for that, what I thought that what I'll do is I'll maintain a queue. So if I could show you in here, I'm taking a queue like 1 2 3 4 5 6. So starting this queue will have all the elements. Okay, now the first time, since there are 3 liked suits that she likes, so it is greater than or equals to 1, so first she will eat the first one. Okay, so if we remove the first one, now it becomes 2 3 4 5 6. Okay, so after first operation we are left with 2 3 4 5 6. Okay, and now still we have 3 liked suits. Now one point also we need to take care of, that there could be one like possibility that the first suit that we eat is one of the liked suit, or like, although this is not the case in here in this example, but there could be a case where this one, the first one, includes in the liked set. Okay, so if it includes, so we will decrement count from the liked one, because as I said that we will continue this operation until and unless our like set becomes liked set of suits become 0. That means we have eaten all the suits. So that's why I'm saying that if we remove the at the very beginning the first suit, we have to check whether it is from the liked suit or not. If it is, then we will do liked minus equals to 1, so that we will remove 1 from that. Okay, so after first operation it was like that. Now after second, like what we'll do in the second operation, so it is nothing, we have to count 4, and 3 elements will just like these 3 2 3. Okay, so 2 3 4 will just come back to the at the end of the queue. So what I'm saying that this 5 6 and now 2 3 4, so these 3 elements which we have counted k equals to 3 as k equals to 3, so these 3 elements I will remove and again put in the back in the end of the queue. So first we'll remove 2, second we'll remove 3 and put it in the back, third we'll remove 4, put in the back, and now we have removed 3 elements and put it in the back. Now what about the fourth one, because k is 4, so we will remove the fourth one, but we won't put that into back, because it shows that the fourth one is to eat. Okay, so I will simply remove this fourth one. Okay, and now again we will check whether that element that we removed was from the liked list or not, and if it is, like as in this case, we will again say liked minus equals to liked minus minus basically. So we will remove 1 from liked list. Okay, now again we'll repeat this procedure, okay, until unless our likes become 0. So now our like is 2. Now let's say what happens. So we have next element that we will start with is 6. Okay, because 5 we have already eaten. Okay, so like how simple it becomes if we use queue. Okay, so now again 3 elements we will put that back into our queue again. Okay, so I'll just copy it. Okay, and 4, and I have just put 3. We have just removed these 3 elements and I have just put it into the bag. So 4 6 2 3, and this was the 4th one. So what I'll do, I will just remove it and will check whether it was from the liked list or not, and it is, as in this case. So again we'll say liked minus minus. Okay, so now liked is 1, as we have removed 5 and 6. Still we are left with this 6, which is from the liked list, so that we have to remove. Okay, so now again we will do the operation. Like what I'll do, I will just get this 6, put it into bag. I will get this 2, put it into the bag like this and remove it from here. I will get this 3 and put it into the bag. Okay, so we have put 3 elements, which is k minus 1. Now it comes to the kth, that is 4th. So here the 4th one is in the front 6. So what I'll do, I'll remove it, and this time we won't put that into bag because it is the kth. Okay, which elements we'll put into the bag? 1 from 1 to k minus 1, not the kth. The kth one we'll just remove and check. Fuck, man. And check. Sorry, I thought it's just off. Anyways, so it is this 4. This is the front element, that is 6. So we will just remove it and we'll check. Okay, we will check whether it was from the liked list or not. So in this case, yes, it was from the liked list. Okay, so we'll say liked minus minus. Now in this case, at this point of time, our liked count becomes 0. Okay, and we will also maintain a e10s, like e10 so far, or answer, which I have written in here, which will be initially 0, and every time we iterate over the while loop, and I'll take while loop, will increment a count of e10 so far by 1. Okay, and the point when liked becomes 0, we will get out of the loop. Okay, so this was basically the problem. This is basically the principle that I used, the sort of solution that I used for my problem. Okay, now if I could show you my code, it is yes, here. So as I said, I'll take the input n and k. So n is the number of suites in the table. Okay, and k is the count, that how much time we will count. Okay, so 1 2 3 4, as in example it was 4. So like k, n and k will take input, and there is a string. What this string implies? Basically this string is sort of binary string. Okay, so 0 says that this is the proof that suite C doesn't like, and 1 means this particular index suite C likes. Okay, so for that, what I'll do, basically I'll count the number of suites that C likes, because as I said now, the moment of time this number of count of suites that C likes become 0, will end the operation. Okay, so that's why. And now we have taken the string as input as well. Now we are declaring a queue. Why? I'm using linked list for the queue. Okay, in the Kotlin. Okay, and there is a liked variable which is initially 0, and now what I'll do, I will iterate over this string, which is basically implies what are the suites C likes and what are the suites C does not. So from I in 0 until n, and if a string ith index of the string, ith index element is 1, that means C likes the suite of that position. Okay, so I just said I just increased liked plus equals to 1. That means I have increased the liked by 1, and also I am iterating over the loop, and I am adding all the like index, okay, from 0 to n minus 1 if I take 0 breadth indexing, okay, in the queue, because initially all the queue elements would be initially in the queue there will be all the elements, okay. So that I have done in here. Now I'm taking our answer variable, basically I'm named it max e10, okay. I don't know why I have taken this as max e10, it could have been e10 as well, anyways. So now in the starting, as the problem statement says, if there is still like if there is at least one liked suite, so that's what I'm checking. If liked is greater than or equals to 1, she will eat the first one, okay. So she will eat the first one. So here what I'm doing is that I'm removing the element from the queue. That q is the name of my queue. Dot poll means that I'll remove the element, and like at the same time what I'm doing, I'm checking that is this suit is the same suit that she likes at that position, okay. So like this queue poll will give the position of that suite, okay. Basically it is the 0th, so I'm just checking a string 0th position, is that 1, is it 1, and if it is, then I will say liked minus equals to 1. I will decrement liked by 1 because we have eaten one liked suit, okay. Now since we have eaten one suit, so we will say max eaten plus equals to 1, we will increment of count. Now our queue comes into the picture. So I'm looping through the queue and I'm saying while queue is not empty and liked is greater than 0, okay. So if queue is not empty and liked is greater than 0, if both the condition holds true, then only we will go into the loop, otherwise we will break out of the loop, okay. And so what I'm doing in that loop, as I said, I will take k minus 1 elements, okay, and put that into the back of our queue. So that's what this loop does. So this loop iterates from 1 until k. Basically 1 until k means 1 to k minus 1, okay. And I'm just taking the elements. Q poll means that I'm taking the elements, okay, removing the elements, okay, and I'm again adding it to the back of our queue, okay. So I will do it for k minus 1 times, okay. And now after k minus 1 time, it is time for the kth element. So for the kth element we will obviously remove it but won't again add it to the back, okay. So again I'm checking the element that we are removing, the suit index that we are removing, we'll check it into the string that is given, whether it is 1 or not, okay, the character that at that position. If it is 1, that means it was from the liked ones. Liked ones means one of the suits she likes. So if it is, so I'll say liked minus equals to 1, basically decrement liked count by 1. And again after all these things, I will, since we have eaten one suit, this is the suite we have eaten, we will say max eaten plus equals to 1. We'll again increment the count and we'll iterate over this loop until and unless our liked doesn't becomes 0, okay. And once our liked becomes 0, we'll return the max eaten. So this was basically the approach behind this solution, and this is the same thing like I have done into the contest as well, okay. The same thing you can say that in the contest as well I have done. So it has passed all the test cases, okay. So that was it from my side. Like I have made only 3 questions video solution. I will try to make more if I could. So yes, I guess this was it from my side. consider subscribing to the channel if you could.